Okay, I'm going to talk about Eulers' theorem. Eulers' theorem, which is a nice, well, there's many theorems called Eulers' theorem, but in this context, there's only one. You'll recall Fermat's little theorem, which says that if A is relatively prime to P and P is prime, then A to the power P minus 1 equals 1 modulo P. Well, Eulers' theorem generalizes this to non-prime. Generalizes this to non-prime P. Well, let's just state it. If an equals 1, if a and n are relatively coprime, then a to the power phi of n equals 1 modulo n, where phi of n equals the totient function, which I introduced in one of the previous screencasts, equals number of integers less than or equal to n, relatively prime to n, relatively prime to n. Well, that's it really. So if n is prime, of course phi of n, well, let's write it out, phi of p equals p minus 1, and so we recover Fermat's little theorem, which is quite nice, quite like that. And what I want to do is to use it, and want to use this to evaluate 3 to the power, let's say 450, not 350, but I want to evaluate the last 3 digits. Of that in decimal. So what I need to do is to work out 3 to the power 450 in brackets modulo 1000. Well, what does Fermat's theorem give us in here? Well, you see, we could just work out that directly just by multiplying out this huge thing and keeping track of just the last 3 digits, but we'll think of a cleverer way to do it. Euler's theorem says that because 3 and 1000 are relatively prime, then we know that 3 to the power phi of 1000 equals 1 modulo 1000, which is useful to know. What's phi of 1000? Well, the factorisation of that is 2 cubed times 5 cubed. So therefore, phi of 1000 equals 1000 times 1 minus 1 half times 1 minus 1 fifth equals 400. So that tells us that 3 to the power 400 equals 1 modulo 1000. But we need, what does it ask us for? 3 to the power 450. So therefore 3 to the power 450 equals 3 to the power 400 times 3 to the power 50 equals 3 to the power 50 modulo 1000. So we need to work out this thing here. It's as well to do this by hand in the screencast, so I'm just going to do it. So I'm going to have 3 and I'm going to square it. 3 squared, 3 to the power 4, 3 to the power 8 and so forth. And what I'll do is when I get up to 32 we'll combine it together. Equals 3, 9, 81. What's 81 squared? Modulo 1000. Well, that's 8 and 64. So modulo 1000, we've got 1, 6, 5 equals 561. Modulo 1000. Yeah, we need the last 3 digits, don't we? 3 to the power 16. Do you see how I don't need to work out, doesn't matter what these numbers are here, because we're all working modulo 1000. Let's work out 561 squared. 5, 6, 1, 6 ones are 6, 6 down 3 to carry, 6 fives are 33. We don't need any of these. And what's this one? 5 and some other stuff which I don't need. 1, 2 down 1 to carry. These cancel. 721. We'll do one more. So 3 to the power 32 equals 721 squared. 2 ones are 2, that's 4, that doesn't matter, that's 7, 1, 4, 14, 18, and some other stuff there, 841. So what we need to do is to work out, you'll remember, we needed to work out 3 to the power 50. Okay, so how do we, that's that, oops, this one here plus another 20. How do we make 20? It's 16 plus 4. So we need to multiply 81 by 721 by 841, all modulo 1000. Well, let's just pile in. Can we see any tricks here? I don't see any particular tricks. We'll just have to do it. Longhand, 841 times 721. It's nice that they all end in 1, so that's 841. Here's my line. 2, 8, doesn't matter. Oops, 7, doesn't matter. 1, 6, 8 and 8 is 16, and 6 plus 7 is 13, so it's 361. What was that? That was 841 times 721. So that's 3 to the power 32 plus 16 is 48. So 3 to the power 48 equals 361. And we need 3 squared, which is 9. So I don't need this one, I need that one there. Is that right? 32 plus 16 plus 2 is 50. That's right. So I need to multiply this one by 9 times 9. 9, 6 nines are 54, 3 nines are 27, plus 5. 27 plus 5 is 32, 2, and then we don't care. So 3 to the power 48 times 3 squared equals 249 modulo 1000. So therefore 3 to the power 50 equals 249 modulo 1000. Therefore 3 to the power 450 equals, well, write it out, 3 to the power 400 times 3 to the 50 equals 1 times 3 to the 50, and we've got that here, is 249. All modulo 1000. You'll notice that the hard bit here wasn't the 400. The 400 here, Euler's theorem did all the hard work for us. The hard bit was working out that 50 there. So Euler's theorem saved us a huge chunk of effort by working out 3 to the power 400. This was the hard bit here. And Euler's theorem saved us from having to evaluate 3 to the power 400, which is quite nice. So what we can say is that 3 to the power, 3 to the power 400, I don't know where that's gone, 3 to the power 450 equals, I've forgotten the answer, well, equals whatever it equaled, which I've lost, modulo 1000. Oh, it's here, look at it. Look at all this rubbish here. There it is. There it is. So 3 to the power 450 equals 249 modulo 1000. So that's the final 3 digits in the decimal expansion. Which is nice, and I'm going to stop there.